Hey y'all, we are Memphis Communiversity and we're back for another Calculus Done Wrong lesson where we wrong calculus before calculus wrongs us. And today what we're going to be doing is we are going to start our second half of our shape of curves units. So we're going to move away from taking derivatives where we have a function and we go for f prime, f double prime and draw sign charts. And instead we are going to start with our graph. So what's going to be given is a graph of f prime, and what we're going to need to do is answer questions about f. So we're going to have our normal questions that we've done previously. We're going to do f increasing, decreasing. We're going to do f concave up or down, f relative min or max, and f inflection point. But instead of using an f prime sign chart that we draw, thankfully we're actually already going to be provided with an f prime graph. So some students don't think that this is too bad, and that's because you don't actually have to do any math. You don't have to take calculus derivatives or anything like that. What you have to do is look at this f prime graph and tell me about a graph that we won't draw, which is f. So we're going to use our rules for f prime. As long as you know what you're looking for, you're going to be good to go. So basically in this video, what we're going to do is we're going to introduce the rules, but the variations that are specific to these sort of questions, and then we're going to try some of these questions. And again, we're just looking at a certain f prime graph and seeing whether that tells us about the f graph. So we might as well get started. So again, what we're doing today is we're doing f prime graphs and seeing how this relates with f graph. These are the most important questions. You'll see that these questions are in the multiple choice, where they'll provide you with an f prime graph, and they often appear on the free response question on the non-calculator section. So they are some of the easier questions in my opinion, because you can practice for them as you practice these rules. So let's talk about our normal rules, our normal grid here. So the first question we always start off with is f increasing. So where's f increasing? Well, that's the same rule as always. It's where f prime is positive. So it's where f prime is positive. Nothing too crazy there. And then f is decreasing, where f prime is negative. But again, it's the same thing as our sign chart videos. When we want to answer the question f increasing, because we have an f prime graph, we're not looking for where that f prime graph is increasing. We'll be looking where f prime is positive. So again, we're not going to sort of see this in the graph. What we're going to see is the other thing on f prime. We're going to see f prime is positive, and that will tell us about a graph that we don't know, which is f, and where that is increasing. You'll see this when we start doing examples. This rule right here, let's go for this one right here. F has a relative min, so f have a relative minimum. Just like normal, you could have used the words local minimum, of course. I don't know how to talk, but f has a relative min at a number. So at x is equal to a, that's our normal rule. F prime goes from negative to positive. You're running downhill and then uphill. So f prime negative to positive. Just like with our first half of our shape of curves videos, we're going to be very specific when we answer these questions. We're going to answer them in complete sentences. We're going to have the question, then we're going to have the justification, which is the rule, and then we're also going to have the answer. So f has a relative min at x equals a. If f prime goes from negative to positive at x is equal to a. And of course, relative max or local max is the opposite. So f has a relative max at x is equal to a if f prime goes from positive to negative. You're running uphill, your f is increasing, to downhill, f is decreasing. F is decreasing at x is equal to a. And again, what we're going to do is we're going to focus on these f prime rules. So what we're not looking for things that look like relative min or maxes, meaning hills and valleys. We're going to be looking on our f prime graphs where f prime goes from negative to positive, as you'll see. So the rules that are going to be slightly different than our sign chart rules, because we were dealing with a second derivative back then, are our concave up or down rules and our inflection point rules. So what is f concave up? Well, the rule that we've been using a lot is that f double prime is positive, and that's certainly valid. But because we have an f prime graph, this is when we don't want to use that f double prime positive side of the rule. We want to use the side of the rule that it contains f prime. So instead of f concave up when f double prime is positive, which is certainly valid, we're going to use the rule f is concave up when f prime is increasing. Because we're provided with these f prime graphs, before we were drawing sign charts of f double prime, so it made more sense to use that f double prime positive rule. But in this case, we're going to be using f is concave up when f prime is increasing. So again, what we're going to be looking for is If the question is f is concave up, we're going to look where f prime is increasing, which is literally where f prime is going up, as you'll see. Then we're going to do f is concave down. That's where f prime is decreasing. It won't look concave up or down in our f prime graph because, again, the f prime graph tells you about f. Finally, we have inflection points. So f has an inflection point. That's when f changes in cavity. Before, what we would do is we would see where f double prime changes signs. But in this case, what we're going to do is we're going to see when f prime goes from increasing to decreasing, or f prime goes from decreasing to increasing. It changes concavity. F prime goes from increasing to decreasing, or decreasing to increasing. Because again, we have an f prime graph, so we want to use a rule that involves f prime. So it's where, so we can say at x equals a, like the other one. At x equals a, where, maybe because is the right word, because f prime goes from increasing to decreasing, increasing to decreasing, or decreasing to increasing. So these are our main rules. Pause the video if you want to copy down these rules. These rules are very important. Once you know these rules, again, the math itself won't be too bad because there won't be any math at all. We won't be taking derivatives. We won't even write any sort of computations at all. What we're going to do is we're going to use these rules, look at a picture, and then immediately have the answer if we know these rules. So again, f is increasing when f prime is positive, f is decreasing when f prime is negative, f has a relative min when f prime goes from negative to positive when you're going downhill and then uphill, f has a rel max is the reverse. Then for this concave upper, again, we're not using f double prime as positive, we're using f prime as increasing, and the reverse for f is concave down. Finally, same thing for f inflection point, we're going to be using the rule f prime goes from increasing to decreasing or decreasing to increasing. If we can take derivatives, we're going to be using that common rule f double prime being positive or negative and changing signs. When we have these f prime graphs provided, like this video right now, we are going to be using these f prime rules because, again, we have an f prime graph. But enough talk for right now with these rules. The best way to do this, of course, is with examples. So let me just draw a nice picture here, and we'll do all 4 questions on this picture. So I'm going to erase this. Erase, erase, erase. But again, knowing the rules is the most important thing. If you don't like to do math, it's going to be okay because you don't have to do any math. If you don't like graphs, well, you're not drawing graphs, you're just looking at graphs, so I feel like it's going to be okay. Let's draw this nice, pretty graph, except let me draw a better graph. Let's see here. Let's put some tick marks here. 1, 2, 3. Let's say we put -1, -2, -3. Let's say our graph looks like something simple to start off with. -1, -2, I want that. So let's say we have this, maybe the simplest graph of them all. And again, it's going to be labeled very nicely f prime. So this is an f prime graph, and we're going to try to answer as much possible those 4 questions. Keep in mind, this is just basically a B. So let's do this. So first thing first, let's just start with the questions. So where is f increasing? The easiest question of them all. Let's start off with something easy. And while we're at it, we might as well answer f is decreasing. So just like our previous videos when we had functions, we were able to take derivatives. Again, all my answers are going to be in the same format. The question itself, then the justification, and finally the answer. So if they ask me where f is increasing, I repeat the words f is increasing. So f is increasing. Then I don't look at the picture because I'm not ready for the picture. What I want to do is I just want to write the rule so that I can tell the world that I know the rule. So where's f increasing? That is where f prime is positive. And then it's going to be on an interval. Now let's look at the picture. But again, you're not looking where f is increasing. You're not looking at increasing things. You're looking for f prime is positive to tell us about f is increasing. So where's f prime positive in this graph? Well, this is a graph of f prime. Where is it positive? It's where it's above the line. So it looks like it's between -3 and -1 and 1 and 3. This is, of course, 1 and 3. So it's going to be on -3 at -1 and 1 to 3. Again, you might be concerned here because this doesn't look like this function is increasing, but we don't care about whether f prime is increasing or decreasing. We only care about whether f prime is positive or not. So where is it positive? Where is it above the x-axis? It's going to be from -3 to -1 and from 1 to 3. If you were to draw a graph of f, but I never do that, what you would see is that from this interval to this interval, and also from 1 to 3, f itself would be going up, but I don't like to draw the graph of f because I feel like it's unnecessary. As long as you know the rules, you're good to go. So that's the answer here. Where's f increasing? You don't look at where the graph provided is increasing or not because that's f prime. What you're looking for is where f prime is positive, and that's where it's above. Let's do the reverse. So where's f decreasing? Again, I like to write down the rule question first. F is decreasing. Then I like to write the rule just to tell the world I know the rule. That rule is f prime is negative. So in this case, I'm not looking for where f prime itself is decreasing. I'm looking where f is decreasing, but I'm not looking for decreasingness because I don't have a graph of f. I'm looking at where f prime is negative, where the slope is negative. So in this case, what is it? Again, you're looking at this part right here. Where is it negative? It's going to be where is it under the x-axis? It looks like it's between -1 and 1. So on -1 and 1. And that's it. Again, notice it's not very difficult if you know the answer and what you're looking for. You're just looking for the positive parts and the negative parts of these f prime graphs. Just like normal, I'm being very specific with my rules. F prime positive, f prime negative. I don't like when my students write like it is positive or slope is positive or even derivative is positive. Just use f prime. F prime is always going to be the subject of all of my justifications when I do these questions. So let's move on. Let's do the other questions. Let's do concave up or down now. So let's erase this. Let's erase. And let's do f is concave up. Where is f concave up? So the rule is just say it and then write down the rule. So in this case, it's f is concave up. And again, f double prime is certainly a valid rule, but because we have a graph of f prime, I'm going to use the f prime is increasing rule. So where f prime is increasing. And now let's go for the answer. It's going to be an interval. So again, I'm not looking at where f is concave up, meaning I'm not looking at this graph and being like, where's the u and where's the upside down u, which is concavity, because I'm not looking at a graph of f, I'm looking at a graph of f prime. So what I'm looking for right now is where f prime is increasing. So where is it going up? So in this case, where is f prime increasing? You're literally looking at f prime. You want to see where it's increasing. So it looks like it's increasing from this point all the way up to this point. So it looks like it's from 0 to 3. 0 to 3. Again, we're not doing some questions that are kind of confusing. What some students get confused about is that the previous question also had the word increasing, but instead it was f is increasing when f prime is positive. It was a different thing was increasing. This question that we have right now is f prime increasing. The previous one, if you want to rewind, was f increasing. F increasing has its own rule. F is concave up involves f prime increasing, but it's two different things that are increasing. F increasing and f prime increasing. And what you want to do is you want to keep them in your mind separate because they're two totally different rules. So that's the answer here. Let's do concave down. So f is concave down. Where's that? Well, f is concave down. I just know the rules very well. You can say f double prime is negative, but I'm going to again say that f prime is decreasing. So in the previous question, we looked where f is decreasing, which was f prime is negative. But in this case, because we're doing f is concave down, that rule is f prime decreasing. So on this graph, I don't need to know where f prime is negative or where f prime is concave down. I want to look at literally where it's f prime decreasing, meaning it's going down. So in this case, it's going to be from here all the way to here, -3 to 0. And that's how it's done. Once you get good at this, you're just going to look at the graph and be able to do all these questions rapid fire because it's the same thing every single time. Don't confuse the words f increasing with f prime increasing. F increasing is its own question. That means when f prime is positive, f prime is increasing or f prime is decreasing is the justification for concave up or down for f. And as you get used to this, you'll sort of see the difference and see what you're trying to look for. But let's do the last two questions. Let's do local min or max and then inflection points. So we're going to erase this. So where does F have a local min? And remember that, of course, local min is the same thing as relative min or relative minimum. So where does F have a local min? Again, I like to justify. So F has a local min, and then I'd like to write the rule. I'll just leave a blank here. It will be at some number. F has a local min at this point because, and the rule is F prime goes from negative to positive because you're running downhill and then you're running uphill. So it's going to be from negative to positive at this point. Maybe you should write more words. F prime goes from negative to positive, but I think this is enough. So what we're looking for is where F prime goes from negative to positive, meaning that it crosses the x-axis going down to up. So in this case, it's going to be this point right here. Notice that F prime is negative and then it's positive. Some students get confused because they're like, oh, the local min seems to be this point right here because this is the minimum. But again, you're not looking at where F prime has a minimum. You're looking at where F prime goes from negative to positive to tell us about F. Again, you don't care about when it says local min or max for increasing, decreasing, or concave up or down or whatever. You're not looking for that on F prime. Those questions have rules which F prime must be governed by, and in this case, going from negative to positive. So that's the only thing I'm looking for, negative to positive. So in this case, it's at x equals 1. Then we're going to do local max. So we're going to change this to minimum and maximum. So maximum is the same thing, but instead of going from negative to positive, maximum goes from positive to negative because you're going uphill, positive and then negative. Don't know what I'm doing with my arm there, but hopefully you see this. F has a local max at x is equal to something. We'll look at the graph later. Let's just write down the rule because sometimes the rule just gives me a point because F prime goes from positive to negative at this point. So where is it here? Well, again, we're looking where F prime goes from positive to negative, positive and then negative. So it looks like it's this little guy right here. He cannot hide from us. It's negative 1 at x is equal to negative 1, and we are good to go. Once you start doing these graphs, you'll be able to answer again these questions very quickly. Oh, look, it goes from negative to positive. F prime, that means that it's the local min. This is the local max, since it goes from positive to negative, and so on. But let's do the last question. Let's not leave him out, of course. We don't want to sort of abandon him. Let's do inflection point. So, erase this guy here. Where does F have an inflection point? So, same thing as normal. Write down the question, then write down the justification, then go for the answer. So F has an inflection point. Inflection point at a certain number. And again, there is a rule with the second derivative, F double prime going from positive to negative or negative to positive, changing signs. But because I have a graph of F prime, I don't want to use that one. I want to instead use the rule that involves F prime, and that's this one right here. So at x, because F prime goes from increasing to decreasing or decreasing to increasing. And it doesn't matter which one it is, as long as it does one of them. So increasing to decreasing or decreasing to increasing. And that's that. So let's look for it. Again, don't get confused with the words increasing or decreasing, because increasing or decreasing is involved in a lot of the rules. F prime goes from increasing to decreasing or decreasing to increasing. We're literally looking at where it's F prime going from increasing to decreasing or decreasing to increasing. So in this case, looks like F prime starts out decreasing and then it goes increasing. So where's the inflection point? This point right here. This little guy, we can spot him from a mile away. Looks like it's going to be at x is equal to 0. Keep in mind, sometimes people accidentally chose the y coordinate because it's so easy to read off the y coordinate here. But again, we're dealing with x's, so it's going to be x is equal to 0. So that's how you do these questions. Again, once you get better at this, you'll be able to answer these questions really fast. I'm just going to run through them and tell you how fast I can do them, just to show off a little bit, I guess. So where's F increasing? Well, that's where F prime is positive. That's from -3 to -1, 1 to 3, because you're above the line. Whereas F decreasing? Well, that's F prime is negative, so that's from -1 to 1, because you're below the line. Whereas F concave up? That's where F prime is increasing, 0 to 3. Whereas f concave down, that's when f prime is decreasing, so negative 3 to 0. Finally, what are the relative min? The relative min is from at x equals 1 because f prime goes from negative to positive. What's the relative max? Well, that's at x equals negative 1 because you go from positive to negative. Finally, what's the inflection point? Decreasing to increasing, it's going to be at x equals 0. So once you do these questions, you're just going to be very good at knowing what exactly to gather from the graph. And in order to gather from the graph the necessary things, you need to know the rules very well. But let's do another picture. We're not going to do the same exact questions, but slight variations of the questions. But you'll see that once you get good at this, these questions are some of the easier questions. Because again, you don't have to do any math. So let's do this. So new picture time. So let's do, we'll have this. We'll have 1, 2, 3, 4. Looks like I'm going to go 1, 2 here. So we're going to draw like this. Nice little semicircle here. And then we're going to have 1, 2, 3, 4. 1, 2. We're just going to draw this line. Then we're going to draw this line. And this is my graph. It's only going to go from negative 4 to 4. So all my answers are going to be on the closed interval from negative 4 to 4. And of course, just like normal, this is going to be an f prime graph. And we're actually going to have another point too. We're going to have f of negative 2 is equal to 3 or something. Hopefully you can tell that this is supposed to be a nice little V here. Maybe I'll redraw it so that this point is exactly here. So we're going to answer some questions. So first off, what we're going to try to answer is where is f increasing and concave down? So oftentimes on the AP exam, on the free response questions, when you have these graph free response questions, the questions of increasing, decreasing, or concave up or down are too simple. So what they like to do is they like to match together and ask it at the same time. But don't worry, even if it's 2 questions in one, we're just going to separate them basically, and we're going to see on what intervals does it satisfy this, and we just need to know the rules. So just like normal, we're going to focus on the rules. So f is increasing. F is increasing. What is that rule? What f is increasing when f prime is positive. And then what we're going to look for is where f is concave down, and we have a rule for that. F is concave down. And again, concave down could mean that f double prime is negative, but because we have an f prime graph, we're going to use instead f prime is decreasing. So it is going to be confusing because you have the words increasing or decreasing, but hopefully you see that it's 2 separate rules. This rule, f is increasing, has this rule, f prime is positive, as the justification, and f prime is decreasing is the justification for the f is concave down question. So even if they have the words increasing or decreasing, it's as long as you keep them straight and know what is increasing. In this one, it's f itself. And then we have a justification in order to find it. And in this one, it's f prime, which is itself a justification for another question. So that's what we're going to look for. We already wrote the question and we already wrote our rule. So now we're going to look at our graph. So again, what we want to look for is where f is increasing, meaning where we want to look at the parenthetical elements, of course, where f prime is positive. So we're going to cover up everything that is the negative part. Looks like f is increasing from 0 to 4 because f prime is positive above this line. But we're also looking simultaneously where f is concave down, which is where f prime is decreasing. So along this semicircle, what we want to do is we want to know where f prime is decreasing as well. So we want to know where the graph is above the line but still going down. So it looks like it's from here to here. Because notice that along this right half of the semicircle, looks like we are definitely above the graph. That means that f prime is 0, above the x-axis, sorry. That means that f prime is 0, greater than 0, which means f is increasing. And also because f prime is literally going down, which means that f prime is decreasing, that would tell me about the graph that I never draw, that f is concave down. So in this case, the answer would be where 2, 2, 4. If you want to try this by yourself, if I can just verbally say the questions. Where is f increasing and concave up? Well, in that part, you would want to try to find where f prime is positive and where f prime is increasing. So it would be from 0 to 2. If they asked where is f decreasing and concave down, you would be looking for where f prime is negative and f prime is decreasing. So it'd be from here to here. Finally, if they ask the question, where is f decreasing and concave up? Well, f would be decreasing when f prime is negative. F would be concave up when f prime is increasing. So you'd be looking for things underneath the x-axis but still going up. So in that case, it'd be from negative to 0. But hopefully you can see that as we're doing this, even if they're combining these questions, it still isn't the worst question in the world. So let's move on. So we're going to erase this. And we're going to fix this interval. We're not going to do -4 to 4. Usually when they do these questions, they don't include the endpoints. So let's be careful about that. But for this question, we are not going to consider the endpoint. So we're only going from -4 to 4. So the next question is find where f has a horizontal tangent line and categorize that as a local max, local min, or neither. So this is just another way to ask local max or min, basically, just in a fancier way. So local max, so characterize, how do you spell character? Character, that's definitely not a spot, character. Eyes as a local max, local min, or neither. So, a lot of words here, but again, don't be intimidated. This is just a local min or max question. Let's try to break it down. So where does f has a horizontal tangent line? So f has a horizontal tangent line. We have our favorite words of the day, tangent line. So f has a horizontal tangent line. So let's review the words tangent line. Well, lines just mean they're lines, of course. Nothing to say there. Tangent means that, actually we can say that lines need slope. When you have a line, you need a point and a slope. So what does that mean about tangent? Well, tangent just means that the slope is going to be the derivative. That is what a tangent line is. The slope is the derivative. What does the word horizontal means? Well, that means that you want your slope to be 0. So in this case, we have a line which needs a slope. The slope is the derivative, and we want that derivative to be a very specific number. We want the derivative to be equal to 0. So in this case, what we do is, where is this going to be? Well, it's going to be at x is equal to 0 here, because that's where f prime is equal to 0. So again, we didn't include the endpoints because sometimes they don't like to include the endpoints because weird things happen at the endpoints. So where does f have a horizontal tangent line? Don't know how to talk anymore. But where does f have a horizontal tangent line? Find where f has a horizontal tangent line. Well, again, you're dealing with a line, so you need a slope. You're dealing with tangent, so you want the slope to be the derivative. And then you're dealing with horizontal, so you want the slope to be 0. You want your derivative to be 0, so it's this 0 right here. Again, we're not including the endpoints. That's just a small little thing because we're on the open interval from -4 to 4. So then all we have to do is characterize whether this is a negative or a min or a max. So what you want to do is just pause the video, think about whether this is a min or max based off the rule. We're going to talk about it right now. So at x equals 0, f has a local something because f prime goes from something to something. So hopefully you sort of answered the question. Let's try to talk about the answer. Notice that f prime goes from negative to positive. So that's a min because you're running downhill and then uphill. F prime is negative and then positive. Your slope is negative and then positive. So in this case, because we're going from negative to positive, it's a local min. We can't categorize the endpoints because again, the endpoints are not included. But keep in mind that neither is sometimes an option. And how would you have neither? Well, that's where you just balance. So for example, if we continued this graph and the graph went something like this, then at this point right here, this would be a neither point. It would still be where f has a horizontal tangent line or where f has a critical point because that's where f prime is equal, that point equals 0. But because you didn't go from negative to positive, meaning f prime, or positive to negative, you went from positive to positive. F prime is positive and then it just keeps going positive. So this is not a local max or a local min. It would be considered neither. But we didn't have that point, so we're going to erase it. So the next question we're going to ask is the very typical inflection point, just to keep asking inflection point. But hopefully you see that this weird phrase, where does f have a horizontal tangent line? That's just where f prime is equal to 0. And it's still easy to categorize things as local maxes or min. Local max is where f prime goes from positive to negative, so there was no local max in this picture. Local min is where f prime goes from negative to positive. There was a local min right here. So let's do inflection points. They're still the same rules, nothing weird about the wording. So I'm going to erase this. Going to erase this, and what we're going to do is inflection point just one more time, because we did increasing concave down as like one combined question. We did local max or min and the weird wording. So now let's do inflection point in the regular wording. So where does f have an inflection point? Well, again, I like to write down my question. F has an inflection point at certain numbers, because at these numbers, f prime goes from increasing to decreasing or decreasing to increasing. Just like before, we're going to use f prime because we have an f prime graph. So at these 2 points, because f prime goes from increasing to decreasing or decreasing to increasing. So once you write this lovely rule, now it's time for the answer. Let's actually look at the graph. But always write down the rule, because you might get points for the rule even if you have the wrong answer. But we're not going to have the wrong answer because we know how to do this. So again, what we're going to be looking for is where f prime goes from increasing to decreasing or decreasing to increasing. So it looks like it's this point right here, because f prime goes from decreasing, it's literally going down, then it's literally going up, because in this case, f is concave down and then f is concave up, because f prime is decreasing, f prime is increasing, so f changes concavity. So it looks like one of the answers is -2. We'll erase this and put more space here, so it looks like it's -2. So because f prime goes from decreasing to increasing, finally, where does f prime go from increasing to decreasing? Just keep in mind that on the semicircle, it does go from increasing to decreasing, of course, so it looks like it's going to be at x is equal to 2 as well. So that's the answer, just your standard inflection point question. You're looking for f prime goes from increasing to decreasing or decreasing to increasing. So in this case, it's here and here. Finally, let's ask one question about this graph that confuses a few people, where it has nothing to do with inflection points or shape of curves, but we already have a graph provided, so we might as well answer it. So I'm going to erase this. It often comes as part of graph free response questions, which is why I want to do this question. What we're going to do is we're going to find the equation of a tangent line. So find the equation of a tangent line. We can just write tan line of this function. We're going to do a different function. We're going to do g, where g of x is 2 of f of x plus x. And what we're going to do is we're going to find it at our point at x is equal to -2. So we talked about equation of the tangent line in our horizontal tangent line question when we did local max or min. But again, tangent line is nothing too crazy. A line is a point and a slope where the slope is the derivative because of the word tangent. So lines, you need point and slope. What do I want my slope to be? Well, it's the derivative because we have tangent. So in this case, just keep in mind that we're not dealing with f, we're dealing with g. So first off, we're going to find the point, g of -2. So this will help me find the point. What you do is you're just going to plug it into our function. It looks like it's 2 times f of -2. And we're going to plug in -2, of course, into our x, so it's going to be -2 as well. Well, what is f of -2? Keep in mind we're not looking at this graph at all to find f of -2, because this graph is of f prime, so I'm not going to be able to find f of -2 from this graph. It has to be a given, and it was given. So in this case, it's 3. So it's going to be 2 times 3 minus 2. So it's going to be 6 minus 2, which is 4. So it looks like that's going to be my point. Again, you need point and slope, where slope is the derivative. So here's my point. All we did was we plugged in -2 into the given function. So it's going to be -2, comma 4. Now what we're going to do is we're going to take the derivative, because that's going to be our slope. My favorite process in the world. So what you're going to do is you're going to take this derivative, g prime of x. Easy derivative enough. Looks like it's going to be 2 times f prime of x plus 1. Then we're going to plug in -2. And we're going to add 1. What some people get confused about is that they look at -2 and they think that they're clever because there's a sharp point here. And they're like, oh, because there's a sharp point, that means that f prime of -2 actually doesn't exist. So this question is invalid. But unfortunately, they are thinking about the right things, but they're thinking about the right things in the wrong way. Sharp points do imply that derivatives don't exist, but it's the derivative of the graph itself. So this graph, f prime having a sharp point at -2, that implies actually that the second derivative of the function at -2 does not exist. So again, f prime having a sharp point at -2, a corner, or something that looks like absolute value, that means that f double prime of -2 doesn't exist. Whatever the derivative is of the graph, which happens to be f double prime, because f prime prime is f double prime, that one doesn't exist. F prime of -2 does certainly exist. Not f double prime, but f prime of -2. It's going to be the y value of this graph, because this graph is of f prime. So what's the y value of this graph? Well, it's -2 as well. But again, don't get confused with these sharp points. They are going to try to trick you with does not exist questions, especially on the multiple choice. But again, this being a sharp point deals with the next derivative, f double prime, but I only need to deal with f prime in this case. So I'm good to go. What is f prime of -2? It's just the y value of this graph. Because this is an f prime graph, looks like it's going to be -2 as well. So it's 2 times -2, -2 plus 1. So it looks like it's going to be -4 plus 1, which is -3. So this is going to be my slope. And just like normal, we're going to write our slope and equation of our tangent line in point slope form, the best form. I don't know where I'm going to do it though, but let's just do it. We can erase this graph finally, I guess, because we don't need it. Let's actually erase the given point. So we're just going to label the given point over here. So now we're going to write the equation of the line on 4g at x equals -2. We are done. It's y minus the y coordinate equals the slope times x minus the x coordinate, but it's -2. So that's why it becomes +2. But that's our question for the day. That's our video. Those were our review questions. Hopefully you gained something out of this. These are, again, very important questions if you want to do well in the AP exam or college calculus exams, because these questions appear so often. There's a nice f prime graph provided, and you answer various questions. The main ones being f is increasing, decreasing, f is concave up or down, f is relative min or max, and f inflection points. And again, if you know the rules, for example, f is concave down when f prime is decreasing, you will know exactly what to look for in your graph. F prime is decreasing, so that's where f is concave down. Of course, especially if you're getting introduced to this right now, it is a little bit tricky. So if you want, be sure to watch our Girls Teach Calculus video in the description of this video, where one of my former students practices 2 more of these examples where she goes over all the 4 main questions. She might explain things better than me, so be sure to check that out. Again, because these appear so often on the AP exam, it is one of the big free response questions that appear most of the years, maybe every single year. So if you're ready for this, if you're ready to just cram for the AP exam, we also created a playlist where I go through f prime graph free response questions, questions 1 through difficulty 1 through 10. So check that out if you want more practice with this. But thanks again for watching. Just like normal, hopefully you gained something out of this. A nice little appreciation of f prime graphs. These questions, again, I don't think are too bad because you don't have to do any math. You're just looking at various portions of the graph which are defined by the rules. But if this was useful for you, give us a like and subscribe, and I hope to see you next time. Thanks again.